Hello everyone, welcome to our channel 2bits. In this video, we will be discussing a LeetCode question, maximum depth of a binary tree. This question is pretty much similar to the previous question we have discussed, that was count total number of nodes in a binary tree, except in this question we will make one slight change. So please watch that before moving on to this one. So in this we are given a root of a binary tree and we need to return the maximum depth of that tree. So what is the depth of a binary tree? So a depth is the total number of nodes from the root to the farthest leaf node. So in this case, the leaf nodes are 4, 5 and 7, but 7 is the farthest leaf node. So the depth for this tree would be 4, as there are total 4 nodes from 1 to 7. So in the previous question, in order to count the total number of nodes, we were adding the current node and the total node from the left and the total node from the right. But in this case, the farthest node can either be in the left or it can be in the right. So we'll add the current node and we will add the maximum of left or right. So for each node, we will calculate the maximum of left or right and then we will add 1 for the current node. So let's say that here our root says that it will add 1 for the current node and it will add the maximum from left and right. So to check in the left, we will go to 2. We will add 1 for 2 and we will take a maximum of left or right. Then we go to the left of 2, we go to 4. We will add 1 for 4. Then we will take a maximum from left or right. As we see, the left and right of 4 are null. So if a root is null, we will return 0 as there cannot be any further nodes. So left and right of 4 are 0. So the maximum will be 0 and we will add 1 to it. So 4 will return 1. Now we go to the right of 2, we see that it is also null, so we simply return 0. From left we got 1 and from right we got 0, so the maximum is 1 and we will add 1 for 2, so it becomes 2. So this returns 2 to 1. Now we got 2 from left of 1. Now we will check right, we go to 3, we will add 1 for 3 and we will check maximum from left and right. So we will go to the left of 3, we will add 1 for 5 and we will check maximum of left and right. So left and right of 5 are null. So for that we will return 0. So left and right are 0 and we will add 1 to it. So the maximum becomes 1. So 5 returns 1 to 3. Then we go to the right of 3. We will add 1 for 6 and we will take the maximum of left and right. So we will go to the left of 6. We will add 1 for 7 and we will take the maximum of left and right. So left and right of 7 are null, so they will return 0. So left and right are 0 and we will add 1 to it, so it becomes 1. So 7 returns 1. Now we will check in the right of 6, that is null, so we return 0. So from left we got 1 and from right we got 0. So the total would be 2. So 6 returns 2. Now 3 got 1 from left and 2 from right. So the maximum is 2. So 2 plus 1 will be 3. So here it returns 3. Now 1 got 2 from left and 3 from right. So it got 2 from left and 3 from right. So maximum is 3 and we will add 1 for the current node. So the total becomes 4. So at each node, we are calculating the left and we are calculating the right. And if we know both, then we will simply return 1 plus maximum of left and right. And if the root is null, then we will return 0. So the code is exactly same to the previous one, only the return statement has changed. Instead of adding both left and right, we will take the maximum of left and right and add it to the current node. So the time complexity for this solution is order of n, where n is the total number of nodes in the binary tree, as each node is being visited once. We can also solve it using level order traversal, and we will check that in the later videos. Thank you for watching. If you liked the video, then please like, share and subscribe to our channel, as it would be really helpful and it motivates us to create more such content for you.